There we go. Record. And I think we are on air. Can somebody confirm if they see that this video is being recorded? Yeah, I think it is. It's the first time I'm using Zoom for recording. But I will cut this embarrassing part out of the video. So, hi everyone. My name is Evgeny, and today we're going to talk about PWA, which stands for Progressive Applications. And I'll show you how we take our websites offline and how they work there. So as everybody know, around 4 months ago, we got a new project which represents the knowledge base and the assessment tool. One of the core requirements for that project was ability to use the whole tool offline. So today, I've got around 30 minutes to show you what was done and how it works technically. Let's get started. So let's start from the basics. What is PWA? The best explanation I was able to find and actually to come up with is this. PWA is a website that looks and feels like a mobile native application. All right, but what makes a mobile application different from normal websites we develop every day for many, many years? Are there any ideas, team? What's so obvious in the mobile application that makes it different from web?
That it runs on mobile.
Good point. What else?
I would say data synchronization, some data locally on the app.
You're digging very deep, but basically from the end user's perspective, the most, I guess, noticeable differences is that it's installable, first of all, right? You can't install a website, but you can install a mobile application. Then, as soon as you click on the icon on your device for any application, first that you see a splash screen immediately, which sort of already gives you a feeling that the application is loading. You have this like icon, brand colored background, and then immediately it opens really fast, really fast, right? It doesn't matter whether you have internet or not. You know that any application on your mobile device will open fast, within seconds, literally. Obviously, mobile applications don't have browsers involved at all. So you don't even see that there's a browser behind this, this browser string and so on. Yet another difference, which sort of relates to our today's subject, is that every application is capable of working offline to a certain degree. So even if you open any application while you're offline, you will still see something loaded. You will be able to interact with the application. You might not be able to get the most fresh data, obviously, since you're offline, but still you'll be able to interact. You will not see something like, oh, you're offline, sorry. These weird offline pages that we usually see in browsers. The last but not the least are native features of mobile devices, like push notifications, like ability to use camera, and so on, right? How do you think, what of these features on the screen, websites can do today, and we as as website developers can build today for web? That's an open question to the crowd.
I think all of them, apart from maybe some of the native features. So whether you can use the local contact address book or GPS and those things that relate to what else is installed on the phone.
Exactly. So basically web can do it all with some asterisks, because some of the browsers or devices don't support it like 100%, especially which in regards to mobile features, like you mentioned, Anthony. So some of the latest and the coolest features for some browsers are still not supported. Otherwise, web can do it all. And now let me give you a demo of the application that was built and show you how it works offline. So what was done here, I took a usual Android device and started recording my screen while interacting with the application. So have a look. On Android tablet, I just go to the website. I immediately get this install website to the home screen pop up. I got it installed. I'm logging into the system. And now what I'm going to do, I'm going to just close the browser. I will turn off the internet. I will close the browser application so that I operate with no internet and I don't have any applications open on the device. Now you can see there's a icon of the website installed on a home screen. And if I go and click, you see the splash screen. And there we go. The app was loaded within a second. With no internet, with nothing open in the background. So it already feels like a native application, and there's no browser. There is a browser behind the scenes, but users don't see it. So it feels like a native application. Let's now go and start an assessment for a test user. I can use the application. So I can change form states, go through this assessment process, go back. You can see that I can start assessment for another person, for instance. Change state, go back. The application saves the state. I can go and edit it again. All states are preserved. Now I'm gonna close this application again. Open it, and all the states, like, they were preserved. Again, I'm still offline. I'm still able to use the application. And the technology preserves all the data that was filled in by a test rater user. Now let me tell you how that works. PWA stands on 3 key technologies: service worker, manifest.json, and HTTPS. In terms of HTTPS, that's quite straightforward. PWA only works through HTTPS, which is secure protocol. The only exception to that is localhost, but that's just for local development. Speaking about 2 other technologies, manifest.json and service worker, they're a bit more interesting than the HTTPS. Let me walk you through each of those. Manifest.json. It's a simple file which represents the configuration of the website, and it lets developers configure how an application will be saved on a device and open from this device. If you can see some basic attributes like name of the application, what's the start URL of the application to show, because obviously, like you've seen on the previous slide, there is no browser string anymore. There's no browser, but we still need to open something. And then there are some other controls, how to open an application, like whether we should open this in the landscape or portrait mode, whether we should show some browser bits or should not, what's the color theme for the splash screen, what's the icon for the splash screen, these kind of things. So this is, manifest is a very simple file, key value, basically. Adding to the website is very, very easy. It's just one reference to this file in the head of the page, and that's it. The manifest is added. As soon as the manifest was added, we are able to validate that browsers are able to actually fetch the file and read it. For instance, this is a screenshot from Chrome, where on the application tab, there's another subtab called manifest. And if manifest is loaded, then Chrome displays all the data from the manifest file. Yeah, here I just added the manifest that I showed you before, and Google Chrome read this file for me and displayed the properties. Very easy, right? Now let me show you what adding manifest to any page means and what it impacts. For demo purposes, I created a very simple static page, HTML page, and added just manifest file to it. It's on my local dev environment. Basically, this is the only page I've got. It has title and image. And since as soon as I opened browser, it offered me to install this application to my home screen. It has the icon, the name of the application here. And if I close the browser, I will see it here, right here. There we go. So this is what manifest file does. Now let me show you and actually walk you through why we need service workers, because this is the most interesting part of PWA. The best definition of service worker I was able to come up with is service worker is a special JavaScript code that installs into browsers to proxy all requests. Originally, I thought that this definition is quite simple, but then smart people told me that actually I have to explain everything here to make it clear. So let's get started. What means special JavaScript? First of all, it's still JavaScript, right? And service worker is no more than implementation of certain events using usual JavaScript. We as a developers control what goes inside. So when I'm going to say something like service worker decides where to take the data from cache or from server or from somewhere else, I mean that we as a developers still decide the logic that goes in there. So basically, what makes this JavaScript so special? The fact that it installs into a browser. Let me explain. Usually, how things work between a website and a server. There's a website in the browser, there's a server somewhere over the internet. Website makes requests to the server asking for data. Server returns this data, something like styles, JavaScript code for interactivity, images, and those files are added to the website, just like this. And then end users sees the web page. As soon as the website is closed, all the data disappears. Browser no longer has to memorize or keep in its memory any information about the website. With service workers, this flow changes a little bit. So as soon as website requests the data, and then website receives service worker, which is still JavaScript, as we know, right? Service worker installs into a browser, which means that it installs outside of the website. The service worker doesn't have any access to the website data. It can still interact with the website through asynchronous messaging system in browsers, but it has no longer access to the objects or the data within the website itself. And That also means that as soon as the website is closed, service worker stays there. It helps service worker to handle background synchronization stuff or handle push notifications. While the website is still closed, service worker can receive notifications from push servers and display them to end users. And the last bit here, service worker proxies all requests. Again, normally website requests the data directly from servers, from a server or servers, and the data is being returned directly to the website. As soon as service worker is installed, these flow changes like this, and website no longer makes any requests to the server. All requests go through service worker from now on, and then service worker decides whether the requests should be sent to server or just the data should be taken from cache and returned back to the website. Now we know the basics. Let's create a new service worker. Tiny bit of code. So this line tells browser that we want to register a service worker. Essentially, navigator is this navigator object is a browser object. You say, hey browser, I've got a service worker, please register it. And it means for browser, please download the file and install it into the browser. It's a piece of usual JavaScript, which means that it can be added anywhere on the page, on the HTML page. This is an example of service worker, but don't worry if you can't read the code, or actually don't read the code, because the purpose of this code is just to demonstrate that 14 lines of code is sufficient to deliver basic offline functionalities. It isn't hard. What's interesting here is the logic, how it works. So let me explain you the logic behind the code. The logic is much more interesting than the code itself. How this logic works when there is no cache and the user, like end user, opens the browser and opens the website for the first time. Website makes a request to, asks for image, for instance, right? Website needs an image. It makes a request. It goes, as you might remember, it goes to service worker. Service worker asks, looks up for cache in the browser cache, and if there is no cache, obviously there is no one because it's the first load of the page. It goes to the server, asks for necessary data there, then it returns it immediately to the website, and asynchronously puts it into the cache. What's important here is that data being added to the cache system asynchronously. The way we would have done this in PHP way, for instance, or backend way, we would have, after receiving data from server, we would put this to cache first and then return it to the website. But since it's a JavaScript and everything is asynchronous, first we deliver the data to end users, and then in the background, without any interfering with anything else, we put this into cache. Now let me tell you what changes when we've got a cache and a user refreshes the page or comes to the website for the second time, or for instance just goes to another page which has some styles and JavaScript from the existing page, which we've already cached. So website still makes requests to the server, which goes through service worker. Now, since we got some data in cache, we can return the data immediately to end user, not even having to bother the network, not even having to go through the internet to the server asking, oh, give me some HTML, give me some images. We have it already in cache, so we can deliver this data straight to the end users. And then in the background, we can make requests to the server, asking for are there any changes in the files that we've shown? And if there are some, we update this data in cache. And as you might have seen, operation number 4 and 5, which is fetching data from server and putting data into cache, happens asynchronously, which means again in the background. And this is where we achieve this offline first strategy. If I were to go back a few steps, imagine there is no internet, right? Website still makes requests to fetch data. Service worker still able to fetch something from cache. The data is delivered to an end user, and if there is no internet, it's fine. Those operations number 4 and 5, they will not be completed, but the website was already rendered for end user. The end user is able to edit, to interact with the website. And it doesn't matter that we didn't get the latest data. We're offline. It's assumed that we don't get the latest data, but we're able to work with a website or web application, however you want to call it. Let me make you a short demo of those 14 lines of JavaScript code which deliver offline functionality. It's still the same index. It's still the same simple HTML file, but I've just added those 14 lines of service worker code. I open localhost, which is my local environment, the same page. What you can see here is that in the cache storage of my browser, which is Chrome in my case, there were 5 files added, including the HTML page that was loaded, alongside with this image, with manifest, with the files for styling of the page. Even though the styling is quite ugly, still styling, there's still a file that has to be cached, and which was cached. So now, when I switch to the network tab in Chrome, and I can go into the emulation of offline mode and refresh the page, I'm still able to get this page from cache. It doesn't matter that some requests had failed. The script wasn't able to update the data for cache, but it doesn't matter. As a user, I was able to see the page, and this was the most important feature of PWA and service workers. Let me give you a demo, or actually an example, how Twitter uses this offline first approach. You might have seen that these, if you use Twitter, obviously, on your phone or tablet, when you open the Twitter application, the first thing that you see after a splash screen, you see the previous tweets you have already seen and read, right? There are images, some content, and styles which have been already cached technically, because users, you in this case, have browsed to these tweets already. So the PWA was able to cache all this stuff in the browser, for instance. You, as a user, is able to interact with this application already. So you can go up and down, you can scroll the page or the application, you can create a new tweet. It will work. All these operations, they don't require internet connection. And then if you open this Twitter application and you do have internet connection, the next thing that you will see within a couple of seconds is this. Sorry, there's a bit of in Russian. But anyway, it says that there are new tweets. And if you want to see the new tweets, then please click on this balloon to see them. That's how Twitter handles offline first. There's yet another very great feature of PWA, which is called pre-caching. Let me tell you what it does. You have seen this picture already. Website makes request to the server. Server returns some data, static content images, and service worker. What happens next? It doesn't get installed immediately in the browser. There's installation phase where service worker can say, hey, I'm not installed, don't consider me as installed unless I load some HTML pages, some maybe heavy images, some maybe scripts, maybe JavaScript application or something, and put this in cache. Which means that we, as developers, are in control of what's being cached. As soon as the users open a website, we can cache pages which have never been visited by this user, but we can request them from server, put them into cache, so that when user, for instance, goes offline, we can show those pages from cache already. It doesn't matter that user haven't visited those pages. A good example of this would be a site of a conference. Imagine you, as an attendee, have opened the conference website, just the homepage. Then you took a train or flight, went to another country, you don't have internet connection, you open the same website again, but you have already not just the homepage accessible, but the program, the schedule, and some other helpful bits, helpful sections, useful sections of that conference website. And you still can browse this offline, like address of the venue for the conference. That's very, very handy. It all can happen on this installation phase of service worker. It's called pre-caching. Cache whatever makes the most sense at the beginning of the user's journey. And only when this caching thing happened, service worker is being considered by the browser as installed, which means that now, from now on, all requests will go through this service worker. Now, I'd like to revise a little bit this definition of PWA. Is it correct that PWA is the website that looks and feels like a mobile application? I really don't think so. The last 15 minutes, we were not talking about the native application, really. We were talking about three things: about HTTPS, about manifest, and about service worker. PWA is a measurable thing. You can measure if your website is PWA or not. Don't let the word application in progressive application phrase fool you. It's not about application, it's about progressive web. So, getting a bit closer to our Drupal realities, Drupal has a great module called PWA, which actually delivers manifest and service worker. So we as developers don't have to write this from scratch. It's sufficient just to install the module, configure it, and boom, we've got a PWA application up and running. We used this project successfully on this module, successfully on our project, which I demoed this time in this presentation, and it worked perfectly well. A few final notes. First of all, we as web developers seriously jump into the mobile market. If somebody told me 3 or 4 years ago that we as a web developers, will be able to deliver some application like functionality working offline on tablets with all these user interactions and the data saving in browser and in application, I wouldn't believe them. But there we go. Now we're doing this, and this is an incredible technology. So we're gonna get a piece of mobile's market for sure. And the second thing is that for clients, it's much better to have one website which works perfectly well for desktop as well as for mobile applications, for mobile devices, which feels like a mobile application, but still is a website, and support just one website and develop just one website instead of having to develop one website for desktop and then still having to develop a separate mobile application that delivers this offline bits only for mobile devices. Some technical notes, if you're curious to play a little bit with the code, there is a reference to my GitHub repository, the code that I showed today in the presentation, but just compiled into working application. And there's also a demo page, which has this working code just deployed to internet. That's it. Thank you very much for your attention. Do you have any questions?
I have a quick one regarding browser implementation and compatibility, because obviously it very much depends on the browser's implementation of the service worker standard, whether and how some of these PWAs are installed and what features are available really on the service worker level. So Chrome is very good, or in fact they may have actually spearheaded the development of the PWA standard themselves. And I know Firefox does it, but like what's your take on kind of like the landscape of being able to do PWA and how to achieve consistency across browsers and user profiles for PWA functionality?
This is a very good question. Basically, there are companies which develop websites, which develop browsers. Some of them, like Google, are very progressive in this kind of stuff. They deliver very great features. Some of the companies, like Apple, surprise, surprise, they're pushing very hard, pushing back very hard actually, because it's a big piece of their cake in terms of the mobile app development. They've got very huge percentage of, I think every transaction, 10 to 15% of each transaction, they get of their interest for any transaction within any application of for iOS, right? Because it all delivers through the App Store. And now here comes the PWA, which means that any website developers uncontrollably can add an application to iOS device and use it. So yes, it is a problem for them more than for users. And they still implement these functions, but with a big delay. In terms of inconsistency, well, for certain devices, for certain browsers, like Safari, for instance, until they will just allow the modern features to happen, they will be very complex to deliver this consistency across the board, unfortunately, because this is outside of developers' control. It's in control of corporations who develop web browsers. But in the meantime, likely there are not that huge percentage of market using Safari. More people using Chrome and Mozilla, which is the significantly bigger piece of market than iOS has in terms of the browser share.
And there are no quirks in implementation differences, because web standards are famously brittle across different platforms. They're not all consistent sometimes, and these especially new ones. And so in your experience, the service worker pretty much work the same across, I mean, in my experience too. So I guess it's pretty good for that, isn't it?
Right, exactly, yes. And especially basic features of service worker, like if you're not talking about push notifications when the browser is closed, for instance, it works perfectly well in all browsers. When it happens to more advanced implementations, then yes, trust them, details here and there, and the discrepancies between the browsers. Otherwise, it all works very well. Any other questions?
I have one more, if I may. Sorry, no, you go ahead, Anthony, first.
So, Ev, you make it sound pretty trivial to choose an architecture or an approach. You build a site so that it's naturally available as a native app as well. So why would you build any other way? Why would you not choose a PWA approach for all website builds?
That's a good question. Because we should choose PWA approach. It costs us, depending again on what you want to get eventually. Basically, installing PWA module for Drupal makes the website already PWA compliant. And if you still, as a developer, like we as developers, can take these further with offline interactivity for forms and pages and so on and so forth. But the basic offline capabilities can be added to any website with very low cost for us and the clients as well, like very low cost. There's no reason not to add this to any website, if you ask me. Because even if, like, worst case scenario, if nobody will ever use, like from end user's point of view, if nobody will ever install a website on their device, end users still get faster pages loading, because all the supporting assets like styles and JavaScript code is being loaded from their local cache of their browser instead of having to request data from the server, which means that they get performance boost. It's worst case scenario. They just get the boost. The site works faster. But what will happen in the real life for most of the web projects, if end users use mobile devices, the website will offer them to install the website on their home screens. And some of the users will do this anyway, because they like this feature, like this website project, whatever. So it means that we will achieve higher open rate or like return rate for that project. So there's no reason not to. Let's put it this way. There's no reason not to include PWA into any project.
And so there's no overall overhead to doing this rather than not doing it.
It just happens in the background. I mean, since service worker is outside of page context, it can't hurt the website itself. So there's no overhead in this sense. Just install it, like especially this Drupal module I'm talking about. It's very well written. Just install it, boom, your site is now PWA compliant. It works offline. It offers to install this website onto mobile devices. And there's no overhead really. It just, you've seen this manifest JSON, simple file, HTTPS, and then piece of JavaScript which operates outside of the website. You don't even need to maintain it. Well, you need to maintain everything. I have to be careful in choosing words, but I mean, normally you don't need to. Chris, you had the other question.
Yeah, I mean, it's a good point. The Drupal module does do a lot of things automagically in terms of generating all the PWA necessary stuff, but it is also opinionated, and it also doesn't have all of the settings that you could want. So, like, if you want to extend it, if you need something different, you do have to go in there, as Ev says, and maintain it yourself a little bit, or kind of change it around. But in terms of plug and play, especially using the Drupal way of doing it, and not just needing to write the implementation from scratch, is quite easy and extremely low cost, if not zero cost. My quick question was, this is more about the technology side. So since there's a lot of stuff going on the browser level that the user doesn't have control over, and that outside JavaScript does not have control over. How is the you know, what about security and about potential attack vectors? Because I can imagine if you register a whole bunch of like closure JavaScript inside these in some of these server worker callbacks in these async functions, like who's auditing that in terms, like the browser, does the browser have mechanisms to audit that properly and make sure that it doesn't overspill into containers and stuff like that? I mean,
a few things. First of all, yeah, to address this point that you're talking about, Chris, all the interaction happens only through HTTPS, first of all, so that there is no man-in-the-middle attacks and like spoofing of the JavaScript files. Also, I just had another point in my head and then it disappeared. But wait a second. I forgot what was the second point. So
security, Drupal installation.
No. Can you ask the question once again? I had an answer while you were asking the question, and now it disappeared.
Potential attack vectors using the service worker API.
There we go. Thanks. Service workers have a context, so you can request context. For instance, request so that service worker can control requests only to a domain or only to a part of the domain. So you can register sort of a scope for your service worker. So it's not just secure because it works over HTTPS, but you're also in control of what scope it controls.
Who has control over that? The browser or
we as the developers?
The developer has. Okay, so that concerns me. I mean, I have not heard of this. Like, I'm just wondering, you know, what are the potential implications of someone trying to use it for malicious purposes? I don't know if those exist or not.
You mean if developers of a website try to do something malicious, not like somebody's breaking this service worker, but developers of a website, but they can't access anything outside of this website. So if you went to a website that is theoretically does something malicious, developers can access only the data for this particular website. They can't access your other websites, like your files or personal data or anything outside of this website.
And how about payload installation once the PWA is transferred to your device? Is that possible? I mean, I guess executing it would be difficult. Yeah, it's sorry, this is probably wandering off too far, but it's interesting.
So when I mentioned that the developers control scope, one important thing is that they can't define scope outside of the current website. Is the highest scope, which means that if you're on the website for the first time, nobody can access to anything that could potentially lead to unwanted behavior. And it's sort of expected that developers of the website control the website and their data, the data on this website, right?
Sure.
Are there any other questions?
Can you get a PWA native app looking system into the app stores? Can you use that as a common form where people search, browse, find, and usually install an app?
That's a good question. That's a very, very good question. From what I've heard, yes. You need to add some small extra bits to the application, but generally, yes. From what I've read, we never did this, unfortunately, but there are some articles in the internet describing how to get this done. So this is doable. Basically, you can get a website inside of App Store with PWA, which is very interesting. So App Store will have websites rather than native applications.
I think it's just a natural place where the users exist. So you want to go through their preferred portal to get to your platform. If people are going to go to the App Store to get an app that does something offline, instead of go to Google and search your site.
Yes, but when I was getting ready to this presentation, I saw very interesting stats. The average amount of applications being installed per user, average, on mobile devices is 0. Like people get to install, when people get new device, they install a bunch of applications they use, like Facebook, Twitter, and something else. And then they basically stop adding new applications. When they in the web, it's much more likely that they will add a website to their home screen than they will want to add they will go to the mobile app store or whatever is the name of the Android store, Android market, I guess, and will search for the app there and install it. It's a very interesting stat. 0 is average installation of new applications per user. Which is a good thinking point. Anyway, but with PWA we get best of two worlds, right? Websites offer to install application, and application can still be found on the App Store or Android market, which is what mobile applications.
I appreciate the point you made earlier about having a PWA site rather than a website and a mobile app to maintain as well. It drives down the cost of getting into both positions and then maintaining both as well.
Exactly, and this is a big thing, really. Because unless you're doing super deep integration with mobile devices, like you're using something that web can't do of mobile capabilities, which is a very narrow set of features these days, by the way, you don't really need pure native mobile application. Any other questions before we leave it there? All right, if this is it, then thank you guys very much for watching and see you soon.
Thank you very much.
Yeah.
Cheers,
Bye-bye.